Okay, welcome to Dimensional Analysis Part 2. In Dimensional Analysis Part 1, we explored the technique, the protocol for determining how to get from one unit to a different unit. And what we learned was it was very effective in taking us through unit conversions, even if it wasn't involving chemistry. For example, currency conversion, going from dollars to euros and vice versa, for example. But what we want to do in this second video podcast on dimensional analysis is we want to take a look at some problems that much more resemble the types of questions that we will see in a typical chemistry class. So let's take a look. Here's what it says. It says 62.43 grams of carbon atoms represents how many moles of carbon atoms? We know a little bit now about the mole. We know that it's a number similar to a dozen, for 12 for a dozen or 2 for a pair. But a mole is much bigger than that. It's Avogadro's number. It's 6.02 times 10 to the 23rd of something. It doesn't have to be atoms. It can be anything. And obviously, these things have different weights. They have different masses. And we're going to need the periodic table to tell us how much 1 mole of any element weighs. So we're going to continue to follow the technique that we learned in the last video podcast, and that is this. We're going to look for any numbers that are in the problem. Here I have 62.43 grams of carbon, so I'll circle that. And then I'll look for what I'm being asked. How many moles? How many what? How many moles of carbon atoms? That's what I'm looking for. So I'll underline that. Now again, the technique allows you to get a good way through the problem without really thinking about what you're doing. So let the pen again guide what your mind is going to do. So we have 62.43 grams of carbon. We'll put that over 1. Why 1? First of all, it's mathematically legal to do that, and secondly, because it holds that place. So 62.43 grams of carbon is what we'll start with over 1 times, put a line right across there, whatever unit we've got on the upper left is going to go in the lower right. Just the unit, not the number. So we don't copy the 62.43 down here, just the unit, not the number. So grams of carbon goes down here. Then what we're going to do is we're going to ask ourselves, what are we looking for? What is it that we want? We want moles of carbon atoms. We've underlined it just to kind of emphasize that in the problem. Moles of carbon atoms. So we'll put that unit on top. So now we're going to need to know how many grams of carbon that 1 mole of carbon atoms weighs. Where do we get that information? Where do we get that number? Well, the answer is the periodic table. Because written on the periodic table is the information that tells us what 1 mole of any element weighs, including carbon. And when I look at element number 6, carbon, I can see that 1 mole of carbon weighs 12.01 grams. 12.01 grams is the mass of 1 mole of carbon. If I was holding 1 mole of carbon in my hand, that's how much it would weigh. So now what we've got is the conversion factor. We now know that 12.01 grams is the equivalent of 1 mole of carbon atoms. Now let me cancel grams of carbon, and I'm left with moles of carbon atoms. That's exactly what I want. It's time for me to get my calculator out now because of the fact that that's what I was looking for. So I'm going to take the 62.43 and divide by the 12.01. Why divide? Why not multiply? Because the 12.01 is on the bottom. If this number's on the bottom, we divide. If it's on the top, we multiply. But it's on the bottom, and this is what I see on my calculator display. It says 5.198168. That's a long number. I can't keep all those significant digits. Well, how many can I keep? I've got 4 significant digits here. All non-zero digits are significant. Ones don't limit my number of significant digits. They are exact. The 12.01, also 4 significant digits. I can only keep 4 significant digits. I'll underline the first 4 numbers. 5.198. I'll look to the 5th number to see if it's 5 or bigger, because if it is, it'll kick that 8 up. It is not. It's only a 1, so I'm left with 5.198. That's 4 significant digits, moles of carbon atoms, and I'm done. I'm finished for number 1. Okay? All right, let's take a look at the second problem. The second problem says this. It says 13.20 moles of nitrogen atoms weighs how many grams? How many grams? Follow the technique. Circle what you know. 13.20 moles of nitrogen atoms. How many what? How many grams? You see how the technique breaks the problem down, makes it easier, so it's not just a bunch of words and a bunch of numbers. Take what you know and put it over 1. 13.20 moles of nitrogen, put it over 1. Times whatever unit is in this position here goes right there. And whatever unit is I want is going to go here. I'm looking for how many grams that 13.20 moles weighs, but I need to do a conversion. So 1 mole of nitrogen weighs how much? Well, it's a little bit more than carbon. Carbon weighed, you recall, 12.0 grams per mole. Nitrogen weighs 14.01 grams per mole. If I were holding a mole of nitrogen in my hand, it would weigh 14.01 grams. So that's the conversion, 14.01 grams per mole. Now what I'm going to do, since I have the unit I want, is cancel. That's not by accident, that's by design. I put moles of nitrogen there because I knew I wanted to cancel there. And I'm left with this number. Now notice this time I'm going to multiply these two numbers because the 14.01 is on top. So I'll multiply these two numbers, and when I do, I get this number on my display, 184.932. Again, a lot of numbers, I can't keep them all. 1, 2, 3, is this zero significant? You bet. Zeros after decimal are significant. That's 4 significant digits there. The 1 doesn't limit me here, the 1 doesn't limit me here, and I've got 14 point, is this significant? Yes. Trap zeros count, 1, 4 significant digits here. So 4 here, I'll take 4. So I'll look at the first 4, there they are, 184.9. The 3 is not big enough to kick that 9 up, so I'll leave it at 184.9, 184.9 grams of nitrogen, and I'm done with number 2, okay? Let's take a look at the next problem. The next problem says this. It says 62.43 grams of carbon atoms represents how many carbon atoms? Now there's a complication in this problem that we're going to be able to deal with, but I need to point that out now, and that is that we cannot go directly from grams of atoms to numbers of atoms. We can't go directly from grams of atoms to numbers of atoms. We have to go through a mole intermediate. Let me show you how that's done. The procedure begins just as it always has. Circle what you know. 62.43 grams of carbon atoms. We're looking for how many grams of carbon. How many grams of carbon? I'm sorry, not how many grams. I'm sorry. Not how many grams of carbon, but how many carbon atoms that represents. Okay. We put what we know over 1, 62.43 grams of carbon over 1, times whatever unit goes here goes there. Grams of carbon, grams of carbon. Whatever our unit I want goes here. But once again, I can't go directly from grams to the number of atoms, so I have to go through the mole intermediate. So I now know from the previous problem that 1 mole of carbon atoms weighs 12.01 grams. So I'll make this intermediate here. 1 mole, 12.01 grams. Now what I'm going to do is cancel that unit with that unit. Don't cross the numbers out, just the units. I'm left with moles of carbon atoms. And now what I can do is whatever unit is here is I'm going to do another step. Whatever the unit's here is going to go right there on the bottom. Whatever unit I want is going to go on top. 1 mole of anything, including carbon atoms, is 6.02 times 10 to the 23rd atoms of carbon per 1 mole of carbon. So there it is. There's the conversion, and I'm looking for carbon atoms. So this and this will cancel, and I'm left with carbon atoms. Now it's time to get out my calculator. I'm going to take this number and multiply by this number, or take this number and divide by this number, and then multiply by this number. So again, it's either multiply these two and then divide by this, or take these two, take this divided by this, and then multiply by that. Be sure to hit the enter button. Be sure to hit the enter button after the first calculation. So when I do that, whether you do it multiplication and division or division and multiplication, you get this number, 3.129299725 times 10 to the 24th. Now, I can only have, let's see, 4 significant digits here. This doesn't count, this doesn't count. 4 significant digits there. This is going to limit me. 3 significant digits here, so I can only have 3 significant digits. So watch what I'm going to do. I'm going to underline the first 3 numbers. 3.129, the 9 is big enough, it's 5 or bigger, to kick that 2 up to a 3. So my final answer becomes 3.13, don't forget this part, times 10 to the 24th carbon atoms, and I'm done. 3.13 times 10 to the 24th carbon atoms represents 62.43 grams of carbon atoms. And I'm done. All right, let's go to the next one. Okay, number 4 says this. Number 4 says 6.82 times 10 to the 31st atoms of boron represents how many moles of boron? I start with what I know, 6.82 times 10 to the 31st atoms of boron, and I look to see what I'm being asked for. I'm looking for moles, okay? I can go from atoms to moles. I just can't go from grams to atoms or atoms to grams without that mole intermediate. So I put what I know, 6.82 times 10 to the 31st boron atoms divided by 1 times whatever unit is there goes there. Whatever unit is there goes there. Whatever unit I want goes there. I'm looking for moles, so just put moles of boron, okay? 1 mole of boron, how many atoms of boron are there in 1 mole of boron? Well, it's Avogadro's number. It's 6.02 times 10 to the 23rd boron atoms. Boron atoms and boron atoms will cancel, and I'm left with moles of boron, which is what I want. Now, it's a simple matter of calculation. 6.82 times 10 to the 31st divided by 6.02 times 10 to the 23rd, and I get this number, 1.132890 times 10 to the 8th. I can only take 3 significant digits here, 3 significant digits here, 3 significant digits. I'll underline the first 3 numbers. The 1.13, the 2 is not big enough to kick that 3 up, so I have 1.13 times 10 to the 8th moles of boron, and I'm done. 1.13 times 10 to the 8th moles of boron is the number of moles of boron that 6.82 times 10 to the 31st atoms of boron represents. Okay? All right. Last question on this video podcast is this one right here. It says, what is the mass of 5.42 times 10 to the 54th atoms of boron? I know I'm going to have to go through a mole intermediate because of the fact that I can't go directly from atoms to mass or mass to atoms. It's okay. No problem. I'm going to circle what I know. 5.42 times 10 to the 54th atoms of boron. I'm looking for mass in grams. 5.42 times 10 to the 54 boron atoms, that's what I know, over 1. Times whatever unit is there goes there. Whatever unit I want goes there, but remember I have to go through an intermediate because I can't go from atoms to grams. That's okay. I know how many atoms of boron there are in 1 mole. It's Avogadro's number, 6.02 times 10 to the 23rd. I'll cancel this with this and continue. Don't take the calculator out just yet because you don't have the unit that you're looking for. You're looking for grams, and you've got moles in this upper right-hand corner. Whatever unit is here, moles of boron, goes here, moles of boron. Whatever unit you want goes there. How do I determine the number of grams that 1 mole weighs? Well, it's not 12.01 like it was for carbon. It's not 14.01 like it was for nitrogen. We're going to have to get the periodic table again, find boron, it's right here, find boron, and it's 10.81 grams. So 10.81 grams is the mass of 1 mole of boron. cancel moles of boron with moles of boron, and I'm left with grams of boron, which is what I want. Now it's time to get the calculator out. 5.42 times 10 to the 54th divided by 6.02 times 10 to the 23rd, enter, times 10.81. If you wish, 5.42 times 10 to the 54th times 10.81, enter, divided by 6.02 times 10 to the 23rd, if you prefer. And in the event, we get 9.73259 times 10 to the 31st. We can only have, well, let's see, we've got 3 significant digits here, 3 significant digits there, 4 significant digits there. I can only have 3. I'll underline the first 3 numbers. Look to the 2, the following number, to see if it's 5 or bigger. It's not. Therefore, I'll take 9.73 times 10 to the 31st grams of boron. I'll see you on the next video podcast.